This is question 53 from section 1 of the 2018 ENGAA paper. So, in this question, we're given a cuboid. We're told it has dimensions x, 2x and y. We're told its volume is fixed as 576 cubic centimetres. And we're told the cuboid has the minimum possible surface area for this fixed volume. And we're asked what's the area of the face of the cuboid which has the largest area. Now, what you'll know is, probably when you've seen this in other forms, there is a misprint on the exam paper and this says maximum. However, indeed, it's minimum, and this is what we'll treat the question as. So, we've got all this information, and it is not in a particularly nice form. It's very hard to interpret. So, we've drawn ourselves a little diagram here, and we're going to try and get this information in algebraic form. So, first things first, we're told the volume is 576, and the cuboid has dimensions x, 2x and y. So we can certainly relate these quantities. So the volume of our cuboid is 2x times y, which is 2x squared y. And we know that's equal to 576, and so we have this expression here. So 2x squared y is equal to 576. Now, if we look, what's the other quantity in this question? Well, the surface area, S, we'll call it. So we want to minimise S. So it would certainly help to have some type of expression for S. So we know S is equal to 2 lots of the sum of each possible area we could have. So it's 2 lots of 2x times x, i.e. the area of this rectangle, plus 2x times y, which is the area of this bottom rectangle, times x times y, which is the area of this side rectangle. So this is our total surface area, because we've got to count each one twice. And 2 times 2, 4, so we get 4x squared plus 6xy, 2xy plus xy, 3xy times 2 to 6xy. So we have these formulae here. So we've got these expressions. What do we want to do? Well, we want to work out when is S minimised, when this is true also. So, if we shove an expression of y equal to some expression of x and shove it in here, we do this, we set y equal 576 over 2x squared and throw it in here, we know this is s as a function of x, and so we can find the minimum of this fairly easily, and we know this is certainly true because we sub the condition in for it to be true. So if we find a minimum of this, we're nearly done. So how do we do that? Well, we've got S here. We can rewrite it as this. 576 times 6 over 2 is 576 times 3, which is a bit of a pain to work out, but comes out as 1728. And if we want to find the minimum, we want to look at the derivative. So we look at ds by dx, which is equal to ax minus 1728 over x squared. And for the minimum, we want this to be equal to 0. So that happens when 8x is equal to 1728 over x squared. So that's times 3 by x squared, divided 3 by the 8, and we get x cubed as the subject. That's 1728 over 8, which comes out as 216. Now, this is a bit of a pain to do, but if you've got this number at the end, it's very reassuring. Because this number's lovely, it's a cube number, it's 6 cubed. And so x must be 6. And if we shove x equals 6 back into here, then we should be able to find y. Indeed, y equals 576 over 2x squared. So 576 over 2 times 6 squared, which is equal to 8. So now we know the dimensions of our cuboid, and we can almost get to our answer. So we've worked out x equals 6, y equals 8. And so here's our cuboid with the updated sides. 2x, x and y. And all we now need to do is make sure we finish the last part of the question, which asks, what's the area of the largest face of the cuboid? So you can easily see that that's got to be 12 times 8, this bottom face here. And 12 times 8 is 96. And that's very reassuring because that's answer C on the multiple choice. And so our answer is C.